Hi, this is Alex from devstories.eu. High Performance Python Async, Episode 2 of 17. The most powerful performance optimization in your asynchronous Python application requires no architecture changes, no refactoring, and no complex configuration. It is exactly 2 lines of code long. Today, we are talking about dropping in uvloop. The standard library async.io event loop is written in pure Python. Uvloop is a drop-in replacement built on top of libuv, the same engine that powers other high concurrency runtimes. It makes your standard Python async code execute significantly faster. Replacing the core scheduling mechanism of your application requires telling Python to abandon its default behavior before it starts doing any actual work. In a web server entry point script, like the main file for a fast API or AIO HTTP application, you implement this replacement using an event loop policy. An event loop policy is a global configuration object inside the standard async.io module. It dictates what kind of event loop gets instantiated whenever the application requests a new one. To swap the loop, you import the async.io module and the uvloop module. Then you call the setEventLoopPolicy function on the async.io module. You pass it a fresh instance of the event loop policy provided by the uvloop module. Here is the key insight. You must set this policy early. The call needs to be at the absolute top of your main execution script, right after your imports. The event loop policy only affects the creation of new loops. If you wait to set the policy until after your web framework has already started, or after an asynchronous database driver has initialized, the standard pure Python loop is likely already running. Changing the policy at that point does nothing to the existing loop. Your code will either ignore uvloop entirely or end up with mixed event loops that cause deadlocks and broken connections. There is an alternative to the policy approach. Instead of changing the global rules for loop creation, you can explicitly create a single uvloop instance. You do this by calling the new event loop function directly from the uvloop module. Once you have that loop object in memory, you hand it over to async.io by calling the setEventLoop function. Why would you choose one approach over the other? Setting the event loop policy is a global override. It guarantees that any third-party library, background task, or framework component in your process that asks async.io for a new loop will safely receive a uvloop. It is the standard choice for a web server where you want uniform performance across the entire application stack. The explicit new event loop approach is narrow. It injects a specific instance rather than changing the factory rules. You use this explicit method when you are managing complex environments with multiple threads, or when you need strict control over exactly which loop is running in an isolated context without mutating the global process state. For standard web applications, the policy override is all you need. The exact mechanism you choose to drop in uvloop matters less than the timing of when you apply it. The event loop policy dictates the foundation of your entire async architecture, so it must be the very first instruction your application executes before any asynchronous context is ever established. That's all for this one. Thanks for listening and keep building.